Hello, welcome to this Android development tutorial brought to you by North Border Software. My name is Gary. What I'll do is just continue with this PlayWave class. There's three methods we need to include here now, and the first is to actually calculate the samples for the sine wave. So there's another variable I want to set up. It'll be for the sample count, because we're going to just work out the exact number of samples we need in a period, so we just need a variable to actually help us to do that. So private int sample count, so we'll use that a little bit later on. Okay, so so let's define a method for effectively setting the wave, and we're going to bring the frequency in from the main activities. So let's make that private void set wave int frequency. Okay. So we'll start to fill in the actually do the calculation of the sine wave now. So first of all, let's work out the number of samples we need, the sample count. So we have sample count based on here. So to work out the sample count, what we need to do is really take the sample rate, be the sample rate divided by the frequency. Okay. So we need a little bit more to it than that. Let's make that lowercase there. Now that's going to return a float value, so we'll just cast that as a float. But what we need to do is then work round that off, truncate that off to an integer. So I'm going to cast the whole lot as an integer. Okay, so that's really worked out our sample count. The next task we need to do is actually define the array. We're going to store the values. Now this is going to be an array of type short. The short primitive stores values between minus 32,768 and plus 32,767. So it's ideal for our 16-bit pulse code modulation. It just fits exactly there. So let's define the array. Samples equals new short, and that'll be of size sample count. There we go. So that's the array defined. Just make that samples, makes more sense. Okay, so a couple of local constants we can define. One will be the amplitude, and that'll be 32,767. So this is all tying in with the work we did with the simulator early on before. So another value will be, constant will be 2 pi. So let's define 2 pi. So 2 pi. What we said, now this is double because all these functions tend to deliver double values. So that's why we need to define the primitives as a double. So we said we use the add-tron approach, which would be 8 multiplied by math. Then we're going to set the arc tangent of that of 1. So typos again. Okay, so yep. So that's 2π defined. The other value we're going to associate with that 2π is the phase itself. So let's set the phase initially to 0. Okay. So the next task is to define the for loop, which is actually going to work out the samples itself. So we're going to go from 0 to the sample count. For int I equals 0, and b for I less than the sample count. Okay, and it'll be I plus plus, we just increment the I. Let's put the brackets in there so we're ready to do that, to fill in the gaps here. So for the samples, quite straightforward. So samples index I is equal, we'll cast this as a short, and what we need to do is quite simply amplitude, and we'll multiply that by the sine of the phase. So it's math sine phase. Okay, I'll just put a semicolon there. So that is the the samples actually calculated. All we need to do then is increment the phase. So phase is equal to plus equals 2π. And it's frequency divided by sample rate. Okay, so lots more typos there to get rid of. Frequency divided by sample rate. Okay, so this plus equals takes the initial value of phase and just adds the new value calculated by these 2π's. So one final thing we need to do in this method is to want to calculate data is to write it to the audio track. So it's audio dot write, and we just need to take samples, and the offset will be 0, and the end of it will be the sample count. Okay, so that's what we've got for that particular method there. Just tidy up the errors. Probably got too many of those brackets in there. Okay, so we need to just go on to do the final two methods for this tutorial. So what we need to do is write a method for starting the waveform. Okay, so it's void start, and let's get rid of that there. Okay, so just to start this, we need to do a few things. Working with the audio track, audio. Now we want to reload the static data. So every time we initiate the waveform, we clear the buffer out and load a new set of samples. And then we need to set the loop because we're going to repeat the periodic loop. So audio dot set the loop points. So the start of the frame would be 0. Let's just put that in there. The end of the frame would be the sample count, and the loop count will be set. Now we're going to set that to minus 1. Set that to value for -1 means it's got an infinite loop. So we could define the number of loops, or we could make it infinite, as we're doing in this case. So the final thing we need to do is set that to play. So that's the method to starting the wave, and just one more method we need to define for this class, and that's to stop the wave. So let's go public void stop, and it's quite simply just audio dot stop. Okay, so that's the PlayWave class actually finished now. I think we'll just leave that here for this tutorial, and then one final task we need to do is go back to fill out the main activity and test the results. So catch you in the next tutorial. Bye bye for now.